Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring graphing linear inequalities in two variables. So to graph an inequality in two variables simply means to plot or shade all the ordered pairs that make an inequality true. Let's look at an example of this process. So when we're graphing linear inequalities, step one is you want to determine the slope and y-intercept for whatever inequality you're graphing. So in this example, it says graph the solution set for y is greater than or equal to 3x minus 2. So we know our slope is 3, or 3 over 1 written as a fraction, and our y-intercept is negative 2. Step 2 is to determine whether to use a solid or dashed line. Now we use a solid line for greater than or equal to or less than or equal to. You can think of it this way. If there's a solid line under the inequality, you're going to use a solid line to graph the inequality. We'll use a dashed line when it's just greater than or less than without the equal sign under the symbol. So let's graph this inequality real quick. We'll begin at our y-intercept of negative 2. We'll go up 3 and right 1, up 3, right 1. We can go the opposite way, down 3 and left 1. All right, we'll connect these with a solid line. Well, I didn't get that very straight. Let me try that one more time. All right, we connect them with a solid line. Oh, I forgot to write down here, we want it dashed or solid. We're using a solid line for this inequality. Now, step 3 is we want to shade where all the solutions are. So I want you to notice that this line separated our coordinate plane into 3 regions. We have region 1, everything above the line, region 2, everything on the line, and region 3, all the ordered pairs below the line. So what we want to do is shade the region where the solutions lie. So all we have to do is pick any point on this coordinate plane and test it into the inequality to see if it's true or false. Now, step 3 says determine where to shade by testing any ordered pair to see if it's a solution. Generally, it's recommended to use the point 0, 0 just to make your math easier. That is, unless 0, 0 falls on the line. If it does, then just choose another friendly point. So in this situation, I'm going to test this ordered pair 0, 0. And I want to see, is 0, 0 a solution to this inequality? So to test it, I go back to the original inequality, y is greater than or equal to 3x minus 2, and I put a 0 for the y, then I put a 0 for the x, and then I see if I get a true statement. So 0 is greater than or equal to, 3 times 0 is 0, and 0 minus 2 is negative 2. So we ask ourselves, is 0 greater than or equal to negative 2? Well, that's a true statement. So yes, 0, 0 is a solution. So if 0, 0 is a solution, we must shade the region where 0, 0 lies. So ask yourself, should I shade region 1 or should I shade region 3? Well, hopefully you said I should shade region 1. Everything in this region is a solution. Now, I could prove that to you by testing more points, but I don't want to make this video too long. So in this particular problem, everything in region 1, whoops, I meant to use a pen here. Everything in region 1 is a solution, and everything on the line, region 2, is a solution. That's because this inequality said you could be greater than, which would be region 1, or equal to, which would be region 2. So region 1 and region 2 are solutions, okay? So the shading on a linear inequality indicates where the solutions of the inequality are found. Name one ordered pair that is a solution to the inequality shown above, and one ordered pair that is not a solution. So if you were going to pick an ordered pair that is a solution, you could pick anything in region 1 or on the line itself, region 2. There could be multiple correct answers here, so you just have to pick one. So I'm just going to pick at random. I'll just pick any random point here. How about this one? That would be the point -2, +2. But you could pick something different from me and still get the answer correct. Now, I want to pick an ordered pair that is not a solution to the system of equations. That means anything in region 3 is not a solution. So maybe I'll just pick something right there. So 1, 2, 3, 4, 0. All right. Now, let's show you a couple more examples of this so you can get an idea of knowing how to shade the line and determining if it's solid or dashed. So in example 2, it says graph each inequality in 2 variables. And we have the inequality 3y minus 2x is greater than or equal to -6. Well, to graph this line, the first thing I need to do is put it in slope-intercept form so I can determine the slope and the y-intercept. So I need to put it in slope-intercept form, I would need to add the 2x to both sides and then divide by 3. So let's take our inequality 3y minus 2x is greater than or equal to -6. If I add 2x to both sides, I would get 3y is greater than or equal to +2x minus 6, and then divide everything by +3. And so that gives me y is greater than or equal to 2/3 x minus 2. So now I can identify my slope as being positive 2/3 and my y-intercept as being -2. Then I must decide, should I make a solid line or a dashed line? To tell, you look at the symbol and ask yourself, is there a solid line under the symbol? Yes, there is. So this should be graphed with a solid line. That's the second thing we need to determine. So let's do that real quick. We're going to begin at -2. I'll use my slope, 2/3, to get additional points. So up 2, 1, 2, 3, up 2, 1, 2, 3. Let's go the opposite way, down 2, left 3, 1, 2, 3, down 2, 1, 2, 3. All right, connect these with a solid line. Now, let's label our regions here. We have region 1, all the points above the line. Region 2, all the points on the line. And region 3, all the points below the line. So what we want to do is see, where should I shade? Should I shade region 1 or should I shade region 3? So to tell, you're going to pick any point you want anywhere on this coordinate plane. To make it easy, I'm going to choose the point 0, 0 just because it makes my math a lot easier. So I'm going to take 0, 0, and I want to plug it into the original inequality, which was 3y minus 2x greater than or equal to -6. So I'll put a 0 for the y, a 0 for the x, greater than or equal to -6. So 3 times 0 is 0, minus 2 times 0, which is also 0, so this is 0. And I ask myself, is 0 greater than or equal to -6? Well, that's true. If you get a true statement, then the answer is yes. 0, 0 is a solution to this inequality. Therefore, I must shade the region of the graph that contains 0, 0. So that would be region 1. So in this particular inequality region, everything in region 1 is a solution, and everything on the line, region 2, is a solution because the line is solid. There's where our solutions are. So let's answer this question. Is 6, 2 in the solution set? Well, let's graph 6, 2. 1, 2, 3, 4, 5, 6, 1, 2 would be right there. That's region 2. So in this case, it is a yes. All right, let's look at another example. We have the inequality x minus 2y is greater than 4. So again, just like the last problem, we must put it into slope-intercept form. So we'll have to subtract the x from both sides and then divide everything by negative 2. So if I subtract x, I get negative 2y is greater than negative x, because we're subtracting it, plus 4. Then I'll divide everything but by negative 2. But be very careful here, because in previous lessons, when we were solving inequalities, we learned that when we divide an inequality by a negative, we must do something special. Do you remember what that thing is? All right, hopefully you said when you multiply or divide by a negative, you must reverse the symbol. So this would become y is less than. And here, this is an understood one. So a negative divided by a negative would be positive 1/2 x. And 4 divided by negative 2 would be minus 2. So in this problem, we know our slope is 1/2 and our y-intercept is negative 2. Now, let's decide solid or dashed. So we look at our symbol. There's no line under that symbol. So this is a dashed line. And I'll show you what that means. Oops. All right, so we'll begin at negative 2. I'll use my slope to get additional points. Up 1 over 2, up 1 over 2. Go the opposite way. And we're going to connect these, this time, with a dashed line. Now let's label our regions. We have region 1, everything above the line. Region 2, everything on the line. And region 3, everything below the line. So to tell which region to shade, I can pick any point on the coordinate plane. But again, I'm always going to use 0, 0 if I can, because it's the easiest to plug in. So I want to go to my original inequality and plug in 0, 0. So 0 for the x, 0 for the y. So 0 minus 0 is 0. And then you ask yourself, is this true or false? Is 0 greater than 4? Is 0 bigger than 4? That's false. So this means no. 0, 0 is not a solution. So if 0, 0 is not a solution, I do not want to shade the region where 0, 0 lives. I want to shade the other region. So in this problem, we'll shade below the line. All right? We're shading below the line. So in this problem, the only solutions lie in region 3 only. Anything on the line cannot be a solution because of the dashing. Anything on the line cannot be a solution because the line is dashed. So they're asking me, is 1, 2 in the solution set? Well, let's graph it. 1, 1, 2. Here's 1, 2. That would be a no. It does not lie in region 3. All right. Now let's look at some special type of lines that I think you might need a little review on, because I believe you've seen these in previous lessons. But in problem C, we have x is less than 4. So here's your x-axis. 1, 2, 3, 4. Here's x equals 4. All right. If you sketch this line, it's going, let me have you write this down. X, if it begins with x and only an x, it's going to be a vertical line that is dashed. So if I want to draw a vertical line through x equals 4, it's going to look like this. All right. Now let's label our regions. We have everything to the left of the line everything on the line and everything to the right of the line. So I need to test one point to see where should I shade. So again, I'm going to test good old faithful 0, 0. So I'm plugging in to this inequality. So for x, I'll plug in a 0, and I'll ask myself, is this true or false? Is 0 less than 4? Well, that's true. So yes, 0, 0 is a solution, which means I must shade the region, in this case region 1, where 0, 0 resides. So in this particular problem, the solution set is region 1 only. Region 2 is not a solution because it's dashed. So they want to know, is negative 3, 0 in the solution set? So let's plot that 1, 2, 3. That would be right here. Yes, it does fall in the shaded area. All right, problem D. We have y is greater than or equal to negative 2. So here's our y-axis. I'll put a dot at y equals negative 2. Now this is going to be, if you have a y only, just want to remind you from previous lessons that that's a horizontal line that will be, in this case, solid, because it has a solid line under the symbol. So I'll draw a horizontal line through y equals negative 2, and then label my regions. I have region 1, region 2, and region 3. So everything above the line, on the line, and below the line. To see where to shade, I will test, again, 0, 0. All right, so I'll put a 0 in for the y and ask myself, is 0 greater than or equal to negative 2? Well, that's true. So yes, 0, 0 is a solution, which means I must shade everything above the line or everything in region 1. So in this particular example, region 1, everything in region 1 is a solution, and everything in region 2 on the line is also a solution because the line is solid. So is 0, negative 5 a solution? Well, 1, 2, 3, 4, 5. That would be right here, and that does not fall in the shaded region, so that would be a no. All right, example 2. The graph of 0.5x minus 2y equals 3 is shown on the grid. Determine which ordered pairs below are in the solution set of 0.5x minus 2y is greater than or equal to 3. So in this problem, we don't need to solve it for y because they've already graphed it for us. What we need to do is label our regions. There's region 1, everything above the line, region 2, everything on the line, and region 3, everything below the line. What we need to do is figure out where to shade so that we know where the solutions lie. So I'm going to use the point 0, 0, and I'll plug it into my inequality. So 0.5 times 0 minus 2 times 0 is greater than or equal to 3. So this would be 0 minus 0, which is 0. And we ask ourselves, is 0 greater than or equal to 3? That is false. So no, 0, 0 is not a solution. So if 0, 0 is not a solution, ask yourself, which region should I shade? Should I shade region 1 or should I shade region 3? Well, hopefully you said I should shade region 3 because 0, 0 is not in the solution area. So in this problem, everything in region 2 is a solution because the line is solid, and everything in region 3 is a solution. Now what we're going to do is test each point and write yes or no. So negative 2 comma 0.5. So that would be left 2 and up a half. That would be a no. 2, -1. That's on the line, so that would be a yes. +2, 1. That would be a no. And 0, -6. So 1, 2, 3, 4, 5, 6. That would be a yes. So the two solutions here are B and D. All right, example 3. Which graph represents the solution set for y is greater than or equal to -7/2x minus 2? And then they've given us 4 multiple choice answers. Now, this is a very common type problem you'll see on a standardized test. So on a standardized test, the first thing I always want to do is see if I can eliminate any obviously bad answers. So first thing I notice is there's a line, a solid line under my inequality symbol, which means my answer must be graphed with a solid line. So right off the bat, I've eliminated A and D, and you now have a 50-50 chance of getting this correct. So let's look at the difference between B and C. In B, 0, 0 is in the solution set. In C, 0, 0 is not in the solution set. So that tells me it should be very easy to test the point 0, 0. So I'll put a 0 for the y. I'll put a 0 for the x. And then I'm just going to see if this is true. Is 0 greater than or equal to, let's see, 0 minus 2 would be -2. In other words, is 0 bigger than -2? That is true statement. Therefore, yes, 0, 0 is a solution. Therefore, 0, 0 must be shaded. So which answer do you think it has to be? Well, hopefully you said answer choice B. And that concludes today's lesson, graphing inequalities in two variables.